Well, the last time we talked about how torque will cause rotational motion. And so if the sum of all of the torques acting on an object is zero, then we will be in rotational equilibrium. Okay? So translational equilibrium means that the sum of all the forces acting on something is zero. Rotational equilibrium means that the sum of all the torques acting on an object is going to be equal to zero. Okay? So when we think about torque, if we're going to start adding together torques to determine whether they're in equilibrium or to determine a missing piece of a torque, like we're going to be doing in the problems we're working today, we need to define direction. And so generally we define a clockwise torque as being negative and a counterclockwise torque as being positive. And this is one where we're not really using angles. So again, you got to make sure your thinking cap's pulled down tight all the way, and you just have to think through the situation to figure out which one's going to be positive and which one's going to be negative. So if we look at example 6.4, it talks about how a girl and a boy are sitting on a seesaw, and they are just sitting so that the seesaw will remain balanced, so that it's not going up and down anymore. They're just sitting on it so that it will remain balanced. And you guys have all played on seesaws before, and you know that if one person is heavier than the other person, sometimes you've got to scoot one person forward in order to make this work. And that's what's happened in this case here. So the girl, we know that her weight is 201 newtons, and she's sitting 1.30 meters from the fulcrum being the point at which the teeter-totter is balanced. So she's sitting 1.30 meters away. The boy is sitting a little bit closer than that. He's sitting a meter away. And so what would you assume then is going to be true of the boy's weight? Is he going to be heavier than the girl, or is he going to be lighter than the girl? Based on your experience, which one of those is going to be true? Okay, so think about that for a second, kind of figure that out in your head as to what you think the answer should be, and then we'll go through and work this out. So if we know that the teeter-totter is balanced, we know that the sum of the torques is zero. So to express that mathematically, I could say the torque of the girl plus the torque of the boy has to be equal to zero, okay? And I know from before that torque is just the perpendicular force times the radius times the lever arm. So if I look at the girl was sitting on this end. Now, is she going to be producing a clockwise torque or a counterclockwise torque? Well, if she would start this teeter-totter moving, she's going to be pulling it down this direction. I mean, we can see that also because that's the direction that her weight is going to be going this direction. That is going to start this into a counterclockwise direction, so that means her torque is going to be positive. So if torque is the perpendicular force times the radius, I'm just going to take 201 newtons times a radius of 1.30 meters, okay? Now, if I add to that the boy's torque, the boy is on this side. He's going to start this going this direction, so that's going to be in a clockwise direction, and so his torque is going to be negative. So I'm going to put a negative sign here. I don't know how much he weighs. I don't know what force he's exerting because of his weight, but I do know that he's 1 meter away from the fulcrum. And so when I add those two together, they have to be equal to zero. So then if I move this to the other side, I'm going to have 201 newtons times 1.30 meters equals basically the weight of the boy times 1 meter. And then when you solve all that, you end up with his weight. I wrote perpendicular force. I also could have written weight because in this case they're the same thing. His weight comes out to be 261 newtons. Okay, so were you right? Did you say, well, the boy should be heavier? If you have to scoot up further, then usually that's because you're the heavier person, right? So hopefully you said because he's heavier, and then you turned out to be right. So again, these problems not super difficult. You just have to make sure that you're thinking and that you get your positive and negative signs correct in order to get everything else to come out right.